Thanks, Terry. Hello, everyone. It's nice to be here. So as Terry mentioned, I'm going to be talking around how we secure APIs with JSON Web Token today. I don't know how many of you are familiar with security in the audience, but hopefully there'll be something interesting for you to discover. So I'm sure you're aware, when you listen to the kind of key speakers, Ross Mason, Greg Schott, Mark Benioff of Salesforce, there's a real emphasis on how organizations are being challenged to unlock data from their core systems of record. But there's a key theme that's missing from both these quotes. There's no mention of security there. If we need to access and unlock the crown jewels, then surely we need to have the security in place that's going to protect those crown jewels. And this is particularly pertinent. Brixton is actually headquartered in Malta, and there was an attack on Malta's largest bank earlier in the year. And they actually lost 13 million euros worth of funds through people executing payments to pay payees using the bank's payment system from within. And so there's been this increased prevalence on cyber attacks that are now taking place. So as organizations, if we're creating more and more APIs, offering more and more capabilities, then we need to take more and more rigor and governance in terms of securing those APIs and what people can do with those APIs. Now, I'm sure many of us are familiar with common API security schemes. HTTPS is by default de facto, but I go into many organizations where we still have services or APIs that are being built that are using HTTP, even within internal networks. Many security architects and security governance teams are still unhappy with that, but services are still using that. So that's kind of the default and the minimum scheme that we need to employ when we're securing our APIs. But there's another lot of security schemes that some of us are familiar with. Basic authentication, that's typically the first one we revert to, but there's a lot of challenges around that because we're putting on the username and password on every request when we're sending it to an API. Some services you'll find are secured using two-way TLS or mutual authentication, but that has PKI challenges in terms of how you distribute and rotate and maintain certificate infrastructure. If you want to deploy an API-led architecture with thousands of APIs, that's not really going to scale. There's also SAML, which comes from the SOA days, which might be a dirty word to some of the members of the audience, but that has more of an enterprise perspective. So it's great for systems and services that have been built to support single sign-on in a distributed enterprise environment. But when we're looking at web scale or being more open and playing nicely with SaaS offerings on the cloud, then that tends to not scale too well. And more recently, we have the OAuth delegated authorization framework, which has some gaps in how it supports authentication and authorization. And they've started to be narrowed down through Google's work a lot around the OpenID Connect initiative. So OpenID has layered additional elements of the framework to support specifically the identification and authentication of individual users and clients. And then JSON Web Token is being used to actually manage the authorization access to an API. And this is where I'm going to drill in and show you a little more information. So when I talk about JSON, just show of hands. Is anyone familiar with JSON Web Token or looked at JSON? Okay, there was at least one person in the audience, that's good. So, great. Okay, so this should look fairly familiar to you. So JSON Web Token is, as it says, it's effectively a payload that's described using JavaScript object notation, and it has three parts to it. So we have a top part of the top part which is the header, which basically contains the algorithm and the token type that we're interested in. And then there's a payload, and in that payload, it contains a bunch of claims that that you can check and verify before you allow access to the service. So I'm going to provide an example of this when I go for a demo. But effectively, there's fields here. So here we have the type bearer, so it's a bearer token. We can see when it's expired, when it was issued, who issued this token. So there's effectively a bunch of metadata. So there's a minimum standard around this token schema and structure, but the applications that you implement JSON Web Token on largely don't have to understand the content that's in here. And there's two ways that we can really work with JSON Web Token when we want to verify that this token is valid. Because systems and services and APIs that receive this token can't just trust it implicitly. They have to establish where the origin of this token and whether the contents of the token are trustworthy. And so there's the concept of the digital signature, which is used in cryptography a lot. And this is a self-describing, self-encoded access token. So the signature is digitally signed with the issuer's private key, and we can use the public key of the issuer to validate that the token has not been modified and is intact. And we can trust the contents. An alternative approach is actually to make calls to the provider using a token introspection endpoint. So we basically send the token to the identity and access management server that's performing the authorization, and then we trust the result that it gives us back. Now, there are some scalability issues with that, particularly if you've got a large API estate. So when we want to introduce this into our API network and our API connectivity landscape, what's the optimal way of employing JSON Web Token verification? We could, in every API, go and implement the JSON Web Token parser, so it understands the token, it does the verification. Or alternatively, using the Anypoint platform, we can create a policy. If we do it via a policy, we can then govern and control how that's applied on every API, and it becomes a configuration only time implementation effort rather than a developer-led effort. So it's great in principle. In practice, however, it's a little bit more complicated. So when we were in Air Malta, we were using mule-free runtime, and there was no JSON Web Token policy out of the box for mule-free. So what we've done, which is what I'm going to show you in a minute, is we've created a custom policy. So the great thing about Mule is, as I'm sure you're aware, it's a framework and there's many extension points. But by leveraging that extension point, we're able to then provide an asset that we can push into Exchange and then share through the API manager across all the APIs that sit in the landscape. So they can all implement this JSON Web Token enforcement policy. So I'm going to give you a demo to keep things interesting and keep things real for me at least. But just before I do that, I want to talk you through the landscape that we're going to be looking at. So effectively, I've got Postman that's simulating some kind of client app on a mobile, or it could be an experience API that wants to consume process API down here. We also have an identity and access management server. So something like Azure AD, or in this instance, we've got Keycloak. We're only using Keycloak because it's an open source Red Hat offering, and it was perfect for our clients' requirements. So Keycloak has a realm, and in that realm, we've registered clients, and those clients then have scopes associated with them. And these scopes are what allow your API to validate that a client can do what it wants to do. And lastly, I then have the API down at the bottom. So the API I have today is a mocked API. It's not talking to any resource server per se. It's just sending back canned responses. But the reason for that is that we're only interested in the enforcement layer, the policy that we're applying to the API. So in this demo, what you're going to see me do is me simulating accessing the client app. The client app is going to make a call to the authorization server, and it's going to identify with a client ID and client secret. So we've pre-registered our client app. This is a client credentials OAuth grant, and what that will do is that will return a JWT token that authenticates the identity of the client app and then provides us with an access token. We will use this access token to then make the invocations to the service, to the API, and depending on the access token we've been provisioned, we'll either be successful or fail. And of course, if we're successful, the policy will determine this based on the configuration that we've configured the policy with, and it will allow the request to pass through and access the data. Okay, so I'm going to have to switch screens through this, and I appreciate some of you are quite far back. So if it's a bit difficult to see, I do apologize. But if you want to pick me up afterwards and kind of drill into these things in more detail, you can do that. Okay. Oh, I bet I have time now this. Yep. Okay, ignore the password that's about to be here. We'll have to change this afterwards. Good job this is not connected to the live environment. Thanks for bearing with me while we load these resources. So, I'm just loading up Anypoint Design Center because I just wanted to give you a preview of the API so you've got some context when you see me executing the operations. So effectively, I need this API mocked instance from one of our banking clients. So we're talking about the concept of a beneficiary here. This API allows us to add a beneficiary or a payee, someone that I want to pay some funds to. And it allows us to add domestic beneficiaries and international beneficiaries. And what I'm going to show you is how we can get a client that only has access to domestic and be able to read international beneficiaries, but cannot actually create international beneficiaries. If I want to create international beneficiaries to pay them funds, I need a different level of privilege and I need to create a different client that gets a different token. So I can show you that just briefly in Keycloak as well. So in Keycloak, we have, I'm logged into the Meetup Realm, and the Meetup Realm is literally just a kind of a container for all the identities and clients and tokens that I want to create. So we have other realms here on this, but I've created 2 clients beforehand. I've got a couple over here, but this is really small. I've created 2 clients in here called a Meetup client and a Meetup client international. And then when I look at the Meetup client, I've got a bunch of scopes that are pre-registered. So this is the domestic one I was telling you about. We've got domestic write, domestic read, and international read. So if we go into Postman here, so I've got my API model, my client interactions with that API modeled in Postman. I guess most of you are fairly familiar with Postman. It's a nice API testing tool, quite graphical driven. And if I go to hit the API at the moment and go to its status endpoint, I've got a dummy access token registered. Dummy access token registered just here. So this token's not valid at all. So I'm actually being prevented. You can see I'm getting back a 401 unauthorized and a bad header. Obviously, we could put more information in the error message that we have here. But so at the moment, I've got no access token. So the API is completely protected. In order to access that API, I need to get an access token. So I'm going to invoke the token endpoint on my access management on Keycloak. So there's a particular URL. And as I mentioned, we've pre-registered the client. So there's a form effectively that you have to submit. So if we had a different API, an Experience API or a mobile app, they would have to go through a client registration process to be issued with these details. These are obviously sensitive, so they need to be kept secret. But I have a client ID and a client secret. I can tell it the grant type that I'm interested in. So this is telling me that I'll get back the access token. And you can also see that I'm asking for the scopes that I'm interested in. So as a client, I'm allowed to ask for whatever scopes I think I deserve, but the access token will only give me back the scopes that have been assigned to me as a client. So I can't ask for the international right, for instance. So if I send that through, I've got a response back here. You can see that it contains the access token and it also contains a refresh token. Refresh tokens can be used because your access tokens expire. Now there's a great tool if you're working with JWT that you can take a copy of the access token and put it in and it will decode it for you. So we can see from this access token that I've received, it's using the RSA256 algorithm. This is because our digital signature is using public and private keys. You can see it's a type JWT, and we've got a key ID. That's the ID of the public key that needs to be used to validate the signature. Then in the data and payload, we can see that I've got my expiry interval here and my, forgotten what IAT stands for. Issued at time. There we go. Thanks very much, the crowd there. So this token cannot be used before that time, and it must be used before the expiration time. And then down the bottom, you can see that we've got the definition of the public key there as well. So that's NAR. That's just the key that needs to be used to validate the signature. So this is color-coded based on the three parts that I showed you earlier. So now that we've got that access token, we can actually make a request to the API, and we'll see that I get a list of beneficiaries coming back. If you don't believe me that that's been how that got set, if we look at the authorization, you can see there's this access token variable here. So I was just using Postman when I made the previous request to populate this variable. So that's adding the access token into my request to the API. So that's getting a list of beneficiaries back from that API. Now if I do a patch request, so I want to update something, I can do that, and that also comes back. It's a 204 because there's no content. I'm patching the resource, it's not giving me any changes back. And based on my scopes, which I didn't show you, so I should have done. So in the JWT token, there's the scopes there. So you can see I've got domestic read and domestic write, which would imply that I asked for a scope that I don't have permission to have. So this is going to get really interesting. Okay, no, so I got the international beneficiary coming back for when I went to read it, which is good. But then when I try to post, we can see that I'm now being warned that I'm international right, I'm missing this scope, I'm missing the permission. So that all makes sense on a high level, but then how do you actually map scopes to your API definition, to the resources and to the endpoints? This is where the magic happens, and this is where it gets a little bit interesting. So this is why we created a custom policy. But just to prove that this works, if I make the request for the Keycloak International, you can see that I get international write and international read. So I've updated, I'm acting as a different client at this point. I've updated my token, and if I post this, you can see that I've got a 201 created, because I've actually gone and created the physical resource. So I can breathe a collective sigh of relief because I've done my work. And then in the Anypoint platform, I want to show you what that looks like. Okay, so when we come into API Manager and we look at the policy, you can see that we've been busy today testing the demo, so all our hard work was well worth it. And you can see that in the policies section, against our API, we've configured this JWT security policy. Now, as I say, this is a custom policy in MuleFree. We've written this, and if I go to edit it, you can see the configuration has been exposed. So you can change this in API Manager without having to go and change code and re-release the policy. So this is a great way of providing a configurable behavior across all your API endpoints on your landscape. So you can see here we've got the path, for instance, to where we go about our public key, because our policy needs to download the public key in order to validate the digital signature. We can see where we're getting the list of valid issuers from. When our token's issued, it's issued from the Meetup Realm. So we obviously need to have that provided to us via the Identity Access Management tool. And then we've got a regex here, which is effectively a map of regexes, where we have the pattern of the endpoint that we want to associate a scope with. So for instance, anything that has the domestic in the URI is effectively mapped to domestic read. So anybody with a domestic read scope can access the domestic URI. For post, put, delete, and patch operations specifically, then you need the domestic write scope. And this goes on and carries on for the international and write and read. And then obviously we've deployed this on CloudHub, which I neglected to mention, and we can go through the log files and we can see when there's been violations based on the output of the log file. So for instance here, that international right call I just made is coming back as an error, and you can see all our pretty debug statements, which could obviously be turned off. How much do you have for time? Now I don't have a lot of time, but just to give you a sense of what it takes to create a custom policy, there's effectively two files when you're creating your own custom policies in MuleSoft that you need to take care of. One is a YAML file. So YAML is just a JSON-like syntax, shall we say, for configuration and property definition. In here, you have to define the name of your parameters, default values. And so this is what generates that UI screen on API Manager. And I showed you the configuration and how you can edit those fields. This is what's responsible for generating that in MuleSoft. And then alongside that YAML configuration, you need a custom policy definition, which is, in essence, to anyone that's developed with Mule, this will look very familiar, even at 50,000 feet away. It's just a Mule XML file. And you've got most of the capabilities you have available to Mule at the runtime, you can define within the context of a custom policy. Now, there are some limitations. It's one XML file. So that means no Java code. You can get to doing Java from Groovy, or you can use main expressions, or you can use DataWeave to define the logic and the syntax for your custom policy. Now, this may have changed in Mule 4. I have to caveat, I haven't looked at Mule 4 yet, so there might be additional deployment options. If you are on-premise, you have access to the entire application runtime of Mule, same on CloudHub, but you can add additional libraries, but that's only on the on-premise version. So I haven't got time to drill through this in too much detail, but it's only 300 lines of Mule configuration, about 50 to 70 of which are Java code. And what it's effectively doing is managing the communications via the access management server on each request and making sure it has a copy of the public key for the issuer that's been identified in the configuration, so that when the token comes in, it can validate the digital signature. And then those validations on that digital signature are effectively implemented in this policy. So the checking of the issuer, the checking of the scopes. And then so, as I say, Mule 4 makes life much, much easier. It has a lot more policies out of the box, which I don't have time to go into right now, but the key one that's there is JWT validation. So that's great. You get this capability from day one. You don't have to build a custom policy. It does it in slightly different ways. But of course, if you're working with a particular identity access management system and it doesn't necessarily conform to the OpenID spec, or it has a slightly different way of working with the job tokens, you could always write a custom policy for moving forward as well. So key takeaways, security is never absolute. There's always some kind of trade-off. I started to allude to it a little earlier when I talked about the two schemes for digital signature validation. So you kind of need to think of security as a multifaceted, multi-layered defense mechanism. So the first layer is obviously making sure all communication, even when it's internal, is HTTPS, so that information is protected in transit. These tokens you do want to protect, particularly if they're going out onto the internet. Yes, it's signed with a digital signature, but if people get hold of them, if you put any sensitive information in there, that's not encrypted. Now, JWT does support the concept of layering on encryption on top, but that's another level of complexity, shall we say, because then you have to manage how your client's going to decrypt that encrypted information. Similarly, if you don't use the digital signature validation approach, but you use the introspection endpoint of your IAM provider, your IAM needs to support as many requests as all your APIs. Or you need to start implementing a caching policy to cache the result of that. So again, there's another layer of complexity that you need to bring in. If you do go down the route of using the self-encoded access token, you need to be very confident that the timeouts that you put in it are not too large. because there's no way of revoking the token. The token's valid until it expires. So that's what I mean. There's a trade-off. There's no silver bullet or one size fits all. But wherever possible, avoid reinventing the wheel. Learn from everyone else's mistakes. Learn from the big boys that are out there, the Googles and Facebooks doing this, and try and employ the best practices and the conventions that they've started to establish. That's it with me. I'm sorry, it was quite a heavy topic for the first one. And then cut me off. No, so yeah, if you would like one or two quick questions, then I'm happy to try and oblige. Otherwise, I'll have to give way to Ryan.